class. Good morning. Yes, come on, join all of you. So you can see today we are going to do the revision of chapter number 1. Okay, and as I have given you my email ID, I found many of you have asked me for few exercises like 1.4, 1.5. You want these exercises to be revised. So we are in the next few days we will be revising chapter number 1, and few queries are also from chapter number 2. So we are planning to do this revision. Ready all of you? Yes, come on, join all of you quickly. Yesterday you have appeared in your CCT 5 exam. I hope you have done well, and so let me start. We are going to do chapter number 1 revision, number system. So whatever I write on the board, please note it down carefully, because this chapter student often find it a bit difficult chapter. So you note down the points whatever I am writing it. This is revision class going on. I will be discussing everything in detail. Okay, right all of you, please. Yes, class. So this is revision class. Revision of chapter 1, that is your number system. Okay. First of all, see, whatever the numbers we have studied so far, that is your natural number, whole number, then you have studied rational numbers, and now you are going to study about irrational numbers. So all these numbers, they are actually your real numbers. They come into the family of this real numbers. These real numbers are of, they are, if you categorize them, you can say real numbers are of two types. One is your rational number, another one is irrational number. So this is your rational number, and just the opposite of it, that is your irrational number. Rational number and irrational number. Now what are rational numbers? What are the properties of rational numbers? A number that can be written in the form of P by Q. A number that can be written in the form of P by Q, where P and Q are integers, where P and Q are integers and Q is not equal to 0. This you have studied so far about the rational numbers. Right, all of you? You can see the board, everything is visible, clear. Please, I request you to note down whatever I am writing very carefully and try to understand. This will help you a lot. I will discuss everything systematically and in detail. Okay, so this is about your rational number. Another thing of this rational numbers, what all types you have studied so far, see, this includes, rational number includes, that you have studied so far, that is your natural numbers, then you have studied about your whole numbers, then next integers. These are the types of what all includes. Rational number family includes natural number, whole number and integers. Natural numbers, you know, they are the counting numbers. Natural numbers are the counting numbers. From the very beginning, when you started studying maths, whenever you are asked to count something, you counted it like this: 1, 2, 3, 4. So that comes naturally when you are going to count. These are called natural numbers. Then you were introduced with whole number in your 6th class. You came to know that along with the natural number, if we include 0, that is said to be the whole numbers family. And then came your integers. The positive and negative natural numbers including 0 are called integers. So about this thing, natural numbers, whole numbers, and rational numbers, they are also your p by q forms, and these all comes in the category of rational numbers. Now at the same time, what is your this irrational number? Irrational numbers are a number that cannot be written, just the opposite, a number that cannot be written in the form of p by q, where p and q are. This can be written in the form of p by q, and this cannot be written in the form of p by q. Right? I hope you have noted it down. Now then comes your rational numbers. Rational numbers, you know the decimal representations. Rational numbers, their decimal representations are of two different types. This is your, we are talking about rational number, right? They are of two different types. Now we are talking about the decimal representation of rational numbers. They are of two different types, like your terminating another one is your non-terminating. Right? So rational numbers can be, if we come talk about the decimal representation of rational numbers, these are of two different types. Either that is going to be terminating or it is going to be non-terminating. But remember, if it is non-terminating, it is a repeating. If not terminating, then it will at least be repeating. Non-terminating but repeating. And this one is either it is going to be terminating or non-terminating but repeating. But in the case of irrational numbers, you will see the decimal representation is, here the decimal representation is non-terminating, non-repeating. Non-terminating, non-repeating. So these are the differences, rational numbers and irrational numbers. Okay, this thing. Now what about, now let us talk about the terminating rational numbers. Terminating rational numbers and non-terminating rational numbers. What is this terminating rational number? And we will talk about this non-terminating rational numbers. Okay, terminating rational numbers are the one numbers in the form p by q where factors of denominator are only 2 or 5 or both. Please mind it. It is terminating. When it is terminating, you see the rational number. If it is your non-terminating, if the factor of the denominator is your 2 or 5 or both, no other number other than 2 and 5 are there in the factors of denominator, in that case that rational number is going to give you a terminating decimal. And same way for non-terminating, repeat, you will find that in the lowest form, see this p by q that we are talking about, that is when it is in the lowest form. Now in non-terminating, in lowest form, the factors of the denominator here. Here you will find the factors of denominator the factor of denominator includes number other than 2 and 5. Other than 2 and 5. Okay. Now in this case, for irrational number you will see that we cannot, this is non-terminating but they have a pattern. But here the non-terminating decimal will be like this. Example, say your 0.31, then 311, 3111, like this. So irrational numbers, we cannot put a birth, they are not, they are not repeating, but they follow a pattern. Though not repeating, but they form a pattern. This you please note it down. Now understand this table carefully. I will discuss them in detail. Come on all of you. I hope everything is visible and clear. Well class, come on. Written it all of you. I hope you are noting it down. And once again, I repeat, whatever has been written over here, I will explain it. Note them very carefully. So we are revision of chapter number 1. We are talking about real numbers. The name of the chapter is number system. But in the number system, so far we have studied about real number. When you go to class 11, you will come to know about another type of number, that is called your complex numbers, right? So right now, we are in the family of real numbers. Real numbers can be categorized into two different types, that is your rational number and irrational number. Rational number, the definition is a number, you have studied rational number in your 7th class, my dear students. I hope you are recalling it. The definition is a number that can be written in the form of p by q, okay, where p and q are integers and q should not be equal to 0. This is the definition of rational number. And if we go to irrational number, a number that cannot be written in the form of p by q. And remember this also, I want to write it, that this irrational numbers, they are actually the numbers of this type. See, I will write it. Cannot be written in the form of p by q, and they are square roots of non-perfect number. They are actually the square roots of non-perfect numbers, non-perfect square numbers. Example, you can see they are your root 5, root 7, that is square root of non-perfect square numbers. This is your irrational number, and this is, we are talking about the non-terminating, non-repeating decimal. So, irrational number, number that cannot be written in the form of p by q. Now, how do they look like? How do they appear, irrational numbers? This is like root 5, root 7. If you try to find the square root of these numbers by division method, you have learned how to find the square root of numbers by division method in your 8th class. If you try to find the decimal representation of such numbers, which are the square roots of non-perfect square numbers. Remember, non-perfect square number, because if you are talking about square root of some perfect square number, say root 4, that comes out to be 2. Now 2 is not an irrational number. This comes in the family of it is not in the family of irrational number. This belongs to rational number. Similarly, your root 5, this belongs to this family. Root 4 belongs to this family. Now if you talk about root 7 is also the square root of a non-perfect square number, so it will go in this family. If you come to root 9 is equal to 3 because 9 is a perfect square number, so this will come into the family of rational numbers. So this is how you can find about your irrational number, how do they appear like, that is root 5, root 7, these are your which are the square roots of non-perfect square number. I hope this thing is clear. Now I am going to rub it. So, and now this rational number includes natural numbers, whole numbers and integers. Natural numbers are the counting numbers 1, 2, 3, 4, and whole numbers, when natural family numbers family along with 0 is said to be the whole numbers. And integers are 1, 2, 3, 4, where the denominator is 1. Say if you say 5 upon 1, so this is an integer. So these all belong to the rational numbers. Natural numbers family is denoted by the symbol of n. Whole number family of whole number is represented by writing w, and integers family is represented by writing z. Integers family is represented by z. This is how you represent them. And now if we talk about the rational numbers and their decimal representation, okay, we are coming to the rational numbers, their decimal representation. Here irrational number and their decimal representation. Now rational number, their decimal representations are of two different types, like either that is going to be terminating or it is going to be non-terminating but repeating. See, non-terminating but repeating. Okay, they are also called recurring decimals, and this one is your non-recurring terminate, which ends, that is division finishes off, and here the division goes on and on and on, and we put a bar, that is called your non-terminating repeating decimal. Now how, by looking at the rational number, you can predict whether that is going to be a terminating decimal or it is going to be a non-terminating but repeating decimal. This we can take help of this part. It says number in the form of p by q, the number which is in the form of p by q, where p and q are integers and they are in the lowest term. Please mind it, whenever you are going to predict about the decimal representations, by looking at it, you make sure that your rational number is in the lowest term. I hope you understand what is lowest term. That is numerator and denominator, they are co-prime numbers. Co-prime numbers. If you don't know what are co-prime numbers, we will discuss it later on. Or let me tell you, co-prime numbers are the numbers which have only one as their common factor, no other common factor. So co-prime numbers are those numbers which have only one as their common factors. So please note it down. If you have not known about this word co-prime number earlier, note it down and you make sure that your p and q are in the lowest form. Then factors of denominator, you need not bother about the numerator. Nothing to do with the numerator. Just go and see the denominator. If the factors of denominators are only 2 or 5 or both, no other numbers other than 2 and 5 are there in the factors of the denominator, that is your q, then that rational number is going to give you a terminating decimal. And in case of non-terminating but repeating, you will see that the factors of the denominator means that is a p by q form, the lowest form, in the lowest form. Denominator, if it includes the numbers other than 2 and 5, then that number is going to give you a non-terminating but repeating decimal. Okay, so terminating and non-terminating. Now in this case, irrational number, they have non-terminating, non-repeating. Remember, non-terminating, non-repeating. Here it is non-terminating but repeating. non-terminating but repeating. So these are the differences between your rational numbers and irrational number. They are just the opposite. This is non-terminating, non-repeating. How does it look like? Take the example. Say 0.31, 311, 311. Like this it goes on and on and on. So dot 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 dot. But you can see this irrational number, their decimal representation, it is not repeating, but they have a pattern. They have a pattern. So whenever you are writing irrational number, some example of irrational number, you either write it in this form, and if you are going to represent it in the form of decimal representation, then show that there is some pattern. You can imagine any pattern. Let us talk about some other examples. Say 1.5001, 5001, 50001, like this. Okay, so you can see some pattern is there. So this is your irrational number. When you are quoting example of irrational number, you need to write this type of show some pattern is being followed. So this is all about in the beginning. This is how we talk about rational numbers and irrational number. Please note it down, and if you have any difficulty, I give you few minutes time. Let me know through the chat box. I hope the board is clear. If not, it is visible, let me know. In my mail ID, I found many of you have asked me for review this exercise 1.4 and 1.5. So tomorrow also we will continue with this revision. In between, if you have any doubts, any queries, you can mail me in my mail ID. I will take up all those problems so that this chapter is clear with you, and I hope coordinate geometry we have covered and thoroughly. So yes. So okay. Lower part of the board is not visible. Okay. Yes. Now let us. Okay. So now let us discuss some questions based on it. We will discuss some question. Okay, I will give you my mail ID. Now let us take some example questions. Say question number 1. Find irrational number between 0.23 and 0.25. Okay, irrational numbers. You are going to find some irrational number between 0.23 and 0.25. Okay, so if you are talking about, see, 0.23 and 0.25, they are your terminating decimals. Okay, 0.23 and 0.25, they are terminating decimals, and they are, because they are terminating, so they are the rational numbers. Now you are going to find some irrational number between two given rational numbers. This is 0.23 and 0.25. So in between, there are some numbers like 0.24. That is fine. There is no doubt about it. But if you write it as simply 0.24, then it is, and you are not showing any dots, then that means this is going to be maybe a rational number, may not be an irrational number. If you simply leave it like this, 0.24, then it leaves the confusion that whether it is a rational number or an irrational number. But if you write it in this manner, this too is fine, 0.23 and 0.25, 0.2, that too is fine. Now the second place of decimal, this is 3 and this is 5. So in between 3 and 5, there is 4. So if you write it as 0.41, then 411, 4111, like this, if you put dot, that shows that some pattern is followed. This is making some pattern, and also this is non-terminating and non-repeating, so this is an irrational number. So between these two decimal numbers, that is your rational numbers, you have this irrational number. Okay, now also you can write, say, 0.23. okay, so you can write 0.23923, and you have placed one more digit over here, 39, then it can be 3993999 dot dot dot. So in this way, there are infinite number of ways you can find the irrational numbers between two given rational numbers. Now, say question number 2 now. Question number 2, check whether this 2 plus root 2 whole square, 2 plus root 2 whole square is rational or irrational. You have to say, check whether 2 plus root 2 whole square is rational or irrational. Okay. So this is square, and we have already done in the chapter of polynomials, that is your identity, So we will apply the identity and find the square of this number. So 2 plus root 2 whole square is equal to, if you use the identity, a plus b whole square, this is your 2 square plus 2 into 2 and root 2 plus root 2 square. Okay. Okay, so this is your 2 plus root 2 whole square, 2 square plus twice a into b plus b square. So this is your 4 plus 4 root 2 plus root 2 square, this is your 2. So this comes out to be 6 plus 4 root 2. 6 plus 4 root 2. So you see this is a rational number, but rational number when added to this part, this is the product of a rational number, and this you know is an irrational number. So this number is an irrational number. So this is an irrational number. Okay. So this is an irrational number. This is how you find the rational numbers and irrational numbers. Now we will give you some notes that how to check whether these are rational or irrational. So we will discuss some important points about irrational numbers. Okay, I hope you have written it down. This is done. So some important results about the irrational number. So you have found this, I have stated you that this is an irrational number, but you may have some confusion why this is irrational. So what all properties are there for irrational number? Because this is a mixture of rational numbers and then again rational number with a product of irrational number. So how to find whether this is an irrational number or rational number? For that, please note down few points. Irrational numbers. Number 1 is your negative of irrational number is an irrational number. Now if you go through some negative irrational number, negative of irrational number is an irrational number. Negative of irrational number is an irrational. Suppose you say root 2. Root 2 is an irrational number. But if I say minus of root 2, negative of irrational number is also an irrational number. Example, minus of root 2. Root 2 is irrational and its negative is also irrational. Then number 2 point. This is sum of a rational and an irrational number. Sum of rational and an irrational number. Sum of rational and irrational number is equal to an irrational number. Just now we have found, say the example just now is 6 plus root 2. This is rational and this is irrational. So this is going to be your irrational number, right? Then number 3, product of a non-zero rational number. Product of non-zero rational number, product of non-zero rational number and an irrational number. And an irrational number is equal to an irrational number. Is equal to an irrational number. So if you are taking the product with 0, say 0 into root 2, that will give you 0 and 0 is a rational number. But if you go for the product of some non-zero rational number, say 5, 5 into root 2, that is product of a rational number, non-zero rational number with some irrational number, this is your 5 root 2. So this is example of, again you get product of non-zero rational number and an irrational number is an irrational number. Okay. Exercise 1.2 question number 3. Okay, we will do that. Some of you are giving me your queries. Definitely you can also mail me and I will clear your doubts. So this is okay. The next, another point, the fourth point, please note it down. The product. So we have seen that product difference and quotient of two irrational number of product difference and quotient of two irrational numbers may or may not be or may not be irrational. May or may not be irrational. Okay. So now let us take example. Product difference and quotient of two irrational numbers may or may not be irrational. So let us see these examples, in which cases they are going to be irrational and on what all cases for being the irrational. So if you take two irrational numbers, say root 2 into root 2, that is product of two irrational numbers, that gives you 2, which is a rational number, right? But if you take root 5 into root 2, please note it down, these simplifications are very important, otherwise you will not be able to do the next part, that is rationalizing the denominator, that is your root 10. So you see, product of two irrational number gives you a rational number, and here the product of two irrational number gives you an irrational number. So product difference and quotient of two irrational number may or may not be irrational. So in this case this is rational, and in this case this is irrational. So we have talked about product. Now if you take the difference, say you take again root 5 minus root 5. Difference of two irrational numbers, you get 0. This is a rational number. But if you take difference of say root 5 minus root 3, is it equal to root 2? Exercise 1.3 question number 2. Okay, I will note it down and we will discuss it. Now, so root 5 minus root 3, this we cannot solve it. This you imagine some, as you do in your algebra, say x minus y. Can you write it? Any solution x minus y is like x minus y. Like that, root 5 minus root 3 is equal to root 5 minus root 3. Okay, this is not equal to root 2. But this is your rational number. In this case, this is an irrational number. So difference of two irrational number may or may not be irrational. Now in the third case, that is your quotient. Okay, division. Now if we are going for division, say root 5 upon root 5. You know they are going to be cancelled and this is equal to 1. 1 is a rational number. 1 is a rational number. So these operations should be clear in your mind. Okay. Then you get say root 5 divided by root 3. This is equal to your, you can write it like this, root 5 upon root 3, and also you can write it under single like root 5 by 3. Okay. So this is an irrational number. This is a rational number. So this point is very important. Product, difference and quotient of two irrational numbers may or may not be irrational. Like that, if you have root 5 plus root 3, this will also be root 5 plus root 3. Often the mistakes that are committed by the students, they write root 5 minus root 3 as root 2. Often this, you write it as 2. This is wrong. Okay. Similarly, if it is root 5 plus root 3, this is not equal to root 8. This is also your wrong. So this you should keep in mind. This is how the thing goes in irrational number. Please let me know if you are clear with these concepts. I know sometimes the video is pausing, it's not clear, but I can't help it. Screen is not clear. मैम बोर्ड कर रहा है. बोर्ड दिक्कत कर रहा है. Now quickly we will do few questions. Now some very important questions that are asked from this chapter are like, just now you have talked about decimal representation. Say convert 0.25 to rational number, or to p by q form, okay. So this is 0.25, that is your terminating decimal. Terminating decimals can be written in the form of p by q, they are rational numbers. So how to go about it? Again, this is a things we have already discussed in our 7th class. So this is 0.25. 0.25 is equal to 25 upon 100. Am I right? Put as many zeros as there are digits after the decimal. There are 2 digits, so you put 2 zeros. Now you cancel them. 25, 4 is 100, so this is 1 upon 4. So this is how you change a terminating decimal into p by q form. Now we will convert some non-terminating but repeating decimal in the p by q form. Convert, say, the 2.4 bar into p by q form, okay. So this is how we do that. See, this is a terminating decimal. Simply we have put the number of zeros and we cancelled it in the lowest term. You get the p by q form. But if it is a non-terminating but repeating decimal, okay, again non-terminating repeating decimals are rational numbers. If they are rational numbers, we can write it in the form of p by q. So the solution goes like this. Let p by q is equal to 2.4 bar, okay. Now because this is one place of decimal, this is actually what? This is equal to 2.444, like this, okay. So we put bar. This is called your recurring decimal, that is your non-terminating but repeating decimal. Now you see there is just one digit which is repeating, that is your 4. So because one digit is repeating, we multiply it by 10. Multiply by 10. This is your, say, one part. Multiply by 10. If you multiply by 10, you get 10 into p by q is equal to 24.4 bar. Okay, because you know, say if you are having a number 2.56 into 10, how do you write it? This is your 2560 and decimal before 2 place, so this is how you write it. So one place goes before, comes over here. In this way you take the product, okay. So because this was your 2.444 dot 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 into 10, when you multiply, 1 4 goes to this side and this is your 24.444, like this. So this is equal to 24.4 bar. So this is how we have written it as 24.4 bar. And the previous equation was p by q equal to 2.4 bar. If you subtract it, then what happens? So you are now subtracting. If you subtract it, 10p by q minus 1p by q, that is your 9p by q, is equal to, see, 0.4 bar, 4 bar gets cancelled. This is equal to 24.4 bar and this is your 2.4 bar. So this part gets cancelled. This is 0.0 and this is your 24 minus 2, that is 22. This is your 22. This is how the subtraction goes, like 24.4 bar and this is 2.4 bar. This 4 bar gets cancelled altogether, you get 0 and this is 22. So this is your 22. Therefore, p by q is equal to 22 by 9. This is equal to 22 by 9. This is the decimal representation of 2.4 bar non-terminating repeating decimal, and see how you have converted into the P by Q form. Now some more example. Please note it down. Similarly, if you take, say, another question number 5, you do it, please. Convert 0.7 bar in P by Q form. In P by Q form. Right? So we start it like this, simply in this manner. Let P by Q is equal to 0.7 bar. Because one place of decimal, this is repeating. So we multiply it by 10. We get 10 P by Q is equal to 7.7 bar. So this is when you subtract. If you subtract it, what do you get? 10 P by Q minus P by Q. This is equal to 7.7 bar minus 0.7 bar. Okay. So this comes out to be 10 minus 1, that is 9 P by Q is equal to 7. 7 bar gets cancelled. Therefore, P by Q is equal to 7 by 9. One more question. Say question number 6 is like this. Say you are asked now, convert 0.63 bar in P by Q form. In P by Q form. So again, in the same way we will start. Let P by Q is equal to 0.63 bar. Therefore, because two places are repeating. See here, two places are repeating. So you multiply it by 100. 100 P by Q is equal to 63.63 bar. So when you subtract this from this, you get 99 P by Q is equal to 63.63 bar, and this is your 63. Therefore, P by Q is equal to 63 upon 99. 63 upon 99. This is not in the lowest term. Cancel it. 3 into 2, 6. 3, 3, 9. Then 3 with 11. 3, 7 are 21. So this is 7 upon 11. Okay. So this is your about how to convert the irrational terminating or non-terminating decimals into the P by Q form. This is some of the very important questions which are asked in the exams. Now we will do, shall I start with your successive magnification? That is your question from exercise 1.4. We will discuss this exercise 1.4 question, that is your visualize 3.765 on number line. Please, today we will do this question, and if you have any doubt, I will write my mail ID. You let me know. This is your this you can see. Okay. So exercise 1.2 question number 2. Okay. Before that, exercise 1.4, this question was asked by someone in my email. So let me first do it, and then we will go to your question, exercise 1.2. So exercise 1.4, visualize 3.765 on the number line. On the number line. You know, number line that we talk about, that is your real number line. Real number line, what you do? You draw this number line. Just now we have done with the chapter of coordinate geometry. So you are quite familiar number line and all that. This is your number line, say this is the point 0. If you mark it 0, Then fine, now this is your 1, 2, 3, 4. This is 1, 2, 3, 4 and this one is 5. Now this point lies somewhere between 3 and 4. This is fine. Between 3 point, this is little more than 3 but less than 4. So you just do it like this. Now 3, this is successive magnification. This is what we call successive magnification. And 3, if this is 3.0, then you know next comes 3.1. In your numbers scale also you see this marking 3.1, then 3.2, this is 3.3, then 3.4, 3.5. Make equal divisions, okay? This has to be equal, 3.4, then this is your 3.5, 3.6, this is 3.7, 3.8, 3.9 and this is your 4.0. So this is how this part is magnified. You start from one side, say 3, don't mark it 4, make equal distances, then finally you come to the point, say this is your 4.0. This is 4.0. Now this 3.76, 3.76 means this is 3.7, 3.8, somewhere in between, little more than 3.7 and less than 3.8. So again this part you bring it over here. This is your 3.7. Then again a line is drawn like this. This is 3.7. This is a line is drawn. So next 3.7 you get 3.71, 3.72, 3.73, 74, 3.74, 75, 3.76, 3.77, 3.78, 3.79 and this one is your 3.80. 71, 72, 73, 74, 75, 3.76, 3.78, 3.79 and 3.80. So this is your 3.80. This part is now magnified. This part. What all divisions are there in between these 2 points? That is your 3.7. You can say this is 3.70, 70, 70, then 71, 72. We read it like 3.71, 3.72, 3.73. This one is 3.73, 3.74, 3.75, 76, like this. Now this is 3.765. So you reach here 3.76. So this point in between 3.76 and this one is 3.77. So this is your 3.76. Now again the line is drawn. So this is your 3.761, 762, 763, 764, 3.761, 3.762, 763, 764, 3.765, 3.766, 3.767, 3.768, 3.769, 3.77, 760, 761, 762, 763, 764, 765, 766, 767, 768, 769 and 3.770. Okay, so this is your 3.770. So now you can see where is your 3.765. This is your this point. This point is your 3.765. This point is 3.765. So in between these two, this is your point between 3.76 and this is your 3.770. This part is magnified and this point is your 3.765. Okay, now all of you please practice few questions from your textbook, and I have given you the mail ID. This one question from your exercise 1.4. Tomorrow we will do this visualize 4.26 bar on number line up to 4 places of decimal. We will continue with it. Thank you very much. Take care. That's all for today. Thank you very much.